All right, PA5, we're going to try to do this in 5 minutes. Most of this is going to be through the debugger here for most of these requirements. Let's go ahead and start the debugger going. We're using the forest fire dataset. We have 3 models. The first one's the one with 2 hidden layers, 3 and 2, so it's relatively small. Let's go and fit. So here, the top part of this is mostly activations. We're going to skip that for now and get to the error portion. So here, we're going to calculate the partial with respect to the output of the mean squared error. That's that formula right there. We're going to get the partial, and then we need to take those weights, allocate them down using the previous errors, the error term from the layer above, and the weights, and the derivative of the net activation. And we get a whole bunch of stuff here. So we can see once we get the errors from this layer, we're bringing them down as the layer from the previous layer and doing that full calculation. Those delta errors, as Bishop describes them, are enough to get us to the partials. These are all the partial derivatives with respect to the various weights. Now we're ready with that as the gradient to do descent using a learning rate. -1 times these partials. And then we're going to do this once for each one of the weights, so there's the weight updates. So let's go ahead and let these models fit. I'm going to pause while I pull the breakpoints and let these models fit. All right, and we're back. We have just finished fitting these models. And now let's go ahead and step through the debugger. We're going to print each one. This is the one with 2 hidden layers, 1 hidden layer, no hidden layers. And you can notice the 0 for the bias term kind of throughout here as we move up. This is the 2 hidden layer model, each with bias terms at each one of the layers. Now let's go ahead and we're going to do a prediction. The 2-minute mark, so we'll try to move this up. So the predictions are pretty straightforward. So we saw some similar code here, but for the predictions, we actually can just use our matrix multiplication without any issues. So we're going to augment with the bias feature. We're going to do the matrix multiplication of the weights and the features. We're going to apply the activation function, which is a sigmoid function throughout. And that's for the hidden layers. And then you come down here, the output layer has a different activation function at the end, but it's roughly similar stuff. So let's just hit the go button. We're getting activations, and now we're here at the output layer. It's spitting out the outputs, and that's going to return the output. So let's go ahead and step out of that. And so that's our prediction. So nothing too fancy there. Here we're going to go ahead and it's running multiple predictions. And we're going to kind of not worry about that. We've gotten this piece of it here. Step back out. I'm going to pause, take off the breakpoints, and get to this demo complete where we can look at our evaluations. Okay, so I lifted all the breakpoints. We actually finally got here. So these predictions are not great, obviously. Here's the truth value. Here's the predicted response. We only use 10 epochs here, so this is not a really great test, but we folded through the predictions through each layer's weights and then the nonlinear activation function. We're at the 4-minute mark here, so we're going to go now and show some sample outputs from a test run and the average performance over the 5 folds. This is basically what we're submitting as the assignment. So let's go ahead and take a look here. Let's first turn off the debugger that we're not going to need anymore. So for the model outputs, this is actually the full run from Forest Fire. And in general, it used about 20 epochs. Still not, great predictive response. It can't predict the zeros here. But the predictions for each one of these models, this is actually the 0 hidden layer. You can see now 1 hidden layer. And eventually we're going to get to predictions that involve 2 hidden layers. And here's these models that are coming out. These give us various root mean squared errors. You can see for each one of these for no hidden layers, 1, 2.